Okay, welcome to the second video in the series, Salt and Boiling Point. Now, who noticed, because I just noticed, who noticed that I had the scales on the wrong side there? And I noticed it at the end of the video when I went to flip it. But anyway, that's just the way things happen. But we'll deal with it and we'll just continue and we'll fix it up right now. So we've got our grid here. Now, in this one here, we've got our table. And from the table series, you should know what's wrong with this table. It's not enclosed for one. Doesn't have a heading for two. All right, but it's got the column headings and it's got the units. So that's not too bad, but we need to enclose the table, put a heading, and that would make it a lot better. But just for expediency, this is what we're going to do. So we've got the mass of salt and we've got the temperature of the water. And so some students wanted to find out, how does the temperature or boiling point of water change when you add more salt to it? And this is what they did. They got a beaker. They got a specific volume of water and they kept it the same, let's say 100 mils, and they boiled it first with no salt and they found it boiled at 100 degrees Celsius. They then added 8 grams of salt and they found it boiled at 100.5. They then got another 100 mils of water and they added 15 and it boiled at 102, etc. Right? So what's their dependent variable? What is the dependent variable that they have been recording? And remember, that goes on the y-axis because according to dry mix, right, dry mix, where should we write this? So we've got room. So we've got dry mix. We need to work out what axis they go on, right? So according to our acronym TAILS, we need a title. But before we can write a title, we have to work out what our variables are, right? We need to make sure our axes are right. Well, we've got them all drawn up. Okay, got them all drawn up. And now with our axes, we need to work out what our dependent and independent variable is, right? So here's our dry mix. Dependent variable is on the y-axis, so there it is. Let's just put a dv there. And it's the one that responds. It's the one that's responding to whatever we're changing. And it's the one that we measure, right? So dependent is the measure. So what are we measuring here? We're measuring the temperature of the water. So that is our dependent variable. So we go temperature of water. And we have to have units, so degrees Celsius. There we go. What about our mix portion, our independent variable? Well, it's the one that we are manipulating. We're changing. Remember the baby example as well? What you change goes on the bottom, or here's the bottom of the grid. We're changing the amount of salt. So the mass of salt. And we put our units in there. So we've got those two now. Now we, of course, can do our title because we know what's happening here. Remember, we can't just go temperature versus salt. We need to have a bit more description. So we would write how the temperature of water changes when various mass of salt are added. So that's a nice long descriptive title. You can make it a little bit shorter. You can say the relationship between the temperature of water and different masses of salt. That could be something like that, but you've got both variables in there and you've got a bit more description rather than just going temperature versus salt, okay, or temperature versus mass. So we've done the title, we've looked at our axes, we've made sure that they are ruled, that we've identified the dependent and the independent variable, and we have placed them on the axes with their units. So what else do we need to do? What was I for? I was for the intervals. So now we need to work out the intervals and make sure that when we do that, it's nice and large, right? Because don't forget about scale. We've labelled, right? We've labelled. So let's have a look here. We've got to look at our minimum and maximum values. So here we've got 0 and to 45 for our salt. So we need to pick something that's going to stretch over to there for 45. And depending upon your grid, you can count how many divisions you've got, okay? And then you look at your maximum value. You find your maximum value. So here our maximum value is 45. And you divide that by how many divisions, and that's going to tell you how much each division is worth. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, because I rubbed one out. So it was 10 before. So we could draw another one there just to make it nice and easy to do the calculations. And so it's saying that each division would be worth 4.5. Well, how about we just round it to 5, right? That's nice and easy. So we go 0, 5, 10, 15. All right, bit down there, 45. So now we've got our data set that goes all the way to the end. What about this one here? Well, we've got 100 and 100.7. Now, here's something interesting. Do we start from 0 or do we not? Some people think, oh yeah, we need to start every graph from 0. Well, if we did that, most of our data is occurring between 100 and 107. So it's only with 7.2 range of temperature degrees Celsius where we're going to get our data happening. If we make it 0 to 100 and try and stretch it out, so we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We could add another one up there, right? Make it 110, but all of our changes are happening in this small spot. We want to stretch it out. So you don't have to start your data, your table from 0 all the time. We could start from 100 and then start from there. Or some people do this. So we'll rub that out. We can start from 0 and then we show that we're breaking the y-axis and then we're using this as 100. So we're saying from there to there represents 100. It's broken. And we're going to be focusing in on the area that we're doing there. That way it's going to stretch it out. So we want to stretch it out. Let's round that up to 8. Okay, so we could go 1, 2, 3, 4, 5, 6, 7, 8. So that's going to give our data happening here, which is nice and taking up a lot of space. So let's do that. 101, 102, 103, 104, 105, 106, 107, 108, and of course that'll be 109. Okay, so we've got our data there. Now we've got to plot it. So remember, X comes before Y in the alphabet. So we go across X and then we go up Y. Okay, so this is plotting your data. And when you plot your data, you want to use an X. Okay, that way, because when you draw your line should go through the middle of the X. If you do it as a dot, and then sometimes it might go on the side of the dot. So try and do it as an X. Let's see how we go for this one. So we've got at 100 at 0. I should say at 0 it's 100. At 8 it's 100.5. So 5, 8's about there. It's 100.5. So that's halfway. Then at 15 it's 102. So go across 15, go up to 102. At 23 it's 104. So 23 is about there. 104 is there. At 30, it's 104, 30, 104. 38, it's 106, so 106.5. And then at 45, it's 107, 107.2. So there's our data. All right. So now we need to think, okay, what are we going to do? We need to connect the data, but do not play dot to dot. Okay, it's not a little dot to dot book that you would do like you when you're a young child to draw a flower or a dinosaur. We want to do what's called the line of best fit. And we're doing that because there's probably errors. I mean, have a look here. At 2 different amounts of salt, they've got the same temperature. So that's probably telling you that one of these values is an error. They didn't read the thermometer correctly, some other part of the experiment may have gone wrong, and they got the same value. So we don't want to draw a straight line there. We want to try and find a line of best fit. Now, this data looks like it's going up in a fairly straight line like that. Okay, there's no definite curve. So we're going to be doing a line here. And the way you do the line is you want to get your ruler and you want to put it so that it tries to average out all the dots. So your ruler is in the middle of all the dots. So that looks like a good line of best fit there. If I was to put it up there like that, we can see a lot of the dots are on this side. We don't want that. We want to try and make it right in the middle. That looks pretty much like in the middle there according to, right. Okay, that looks not too bad. So that's our line of best fit now. In future videos, of course, we're going to be looking at how you read values from something like that. But that's how you draw your graph. You've got all the features there. It's nice and broad. You've got your line of best fit. And some people may even suggest that you can put little circles around those that are obvious errors. So you could circle that and circle that. okay? Depends on, you know, how bad they are. If it's up like this, that's definitely a big error. So that's how you draw the graph. Hope that makes sense. I'll see you, oh, we got the scale, better tick that. I'll see you in the next video where we can add a little bit more other features and get you becoming a graphing ninja. All right, see you then.